So good, we are doing well. And we pray that we shall continue with that same spirit of enthusiasm to learn and to know more. Just a reminder to everyone that you can actually go to our YouTube channel, Forum Network, to go and see the day 1, day 2, day 3 trainings for your own practice. And we shall be sending the registration link in the chat. And remember the training materials, the same link which we've been sharing. That's where all the training materials are. For the WhatsApp group, we got a link yesterday and we shall continue also sharing it with you. At this moment, I want to hand over to Professor Rogerio to give us a remark before we start the training. Over to you, Professor.
Good afternoon, everybody. Can you hear me? Okay. Good afternoon, Foreign Secretariat. Good afternoon, facilitator and participant. And welcome to the 4th day of this art training. From the participation these 3 days and today's 4th day, I noticed a lot of strong engagement of the participants and with the facilitators. That makes us really feel happy because that was the reason which made us organize this training, just by recognizing that people have a limitation in terms of data analysis, and R is one of these software which can help people analyze their data very easily, given that it's a free software. So guys, let's make useful of this software, of this training, so that we address all these constraints of data analysis that normally we face. With this, I would like to wish you a wonderful training session today, and thank you very much.
Thank you so much, Professor, for those remarks. May I remind the participants that we are going to share the registration link with you in the chat, so there's no need for you to be writing your name and contacts in the chat. We would require you to fill in the Google form where the link we shall share in a moment. At this moment, I would like to call upon our facilitators to take over with the training. Over to you, Professor Susan Balaba. Okay. Hello, everyone. Good afternoon. Just give us a little time for Prof to sort out her microphone. But maybe as we wait for her to... Is that okay? Okay. Talk. I can hear you. You can... Sorry? Okay, as per the assignment we had yesterday, we had agreed that you're going to share something before we move on to something new today. I'm just wondering if there are some participants who tried and they want to show us how to merge 2 data sets. Remember, within the slides, we talked about there are different approaches on how you can
you can merge your data. Maybe you have data from different regions or from different plots, depending on what really that you want to do. Or you have secondary data from somewhere and you need to emerge it such that you can be able to go ahead and do the analysis. So can we get some participants to show us how to go about that? Those that tried yesterday.
Sorry, Dr. Helen, just give me a moment for Amito to give me rights to be the host.
Okay. Kindly give her a second. And okay, for the, as we wait to sort out just some few technical issues, can you type in the chat if you've, so far things that you've learned, just type in the chat and then we see how far you've gone with the learning of our programming.
Okay. Hello, can you hear me? Let me connect this and see that to go through. Hello, can you hear me? Okay, fine. Dr. Helen, go ahead and let them present for 15.
So who should we upgrade?
I can see Mike, Rashid Okoth.
Okay.
Maybe you can give him the chance.
Okay, Rashid, we have promoted him.
Okay, thank you. Okay, let me.
Rashid, you can talk. Rashid, could we have another person?
I'm checking through the responses to see whether we can get somebody. Maybe we can ask the participants, those that are ready to rewrite, just say, yes, I'm ready. So, okay,
Rashid has put his screen on. He can unmute himself and talk. Rashid, can you unmute yourself?
Yes, can you hear me, Doctor?
Yes, please go ahead.
Okay. So I was saying that I have already set my working directory. I would like to skip that step. And I want to present on merging of the weight A and weight B document that we received in our drives. So since I've set the working directory, I want to start by importing the data. And I'm going to use the read command. That is the read .csv. And then we import the data which we do want, which is the weight. We have weight A and then weight B. So I would like to start by the weight A. And we run that command. Sorry.
You need an extension on the weight A.
.csv.
Yeah.
The CSV, I don't have the extension. Doctor, may I get some help?
After the file name. After weight.
Thank you, doctor.
Yes.
.csv.
Yes.
Okay, thank you. Then we do run that one. So it's still the error, doctor?
Do you check the name again?
Okay.
It is capital W.
Okay, thank you.
Is it? No, it is not. It's what this is.
It is small w.
Sure.
Yes,
Run
it is.
again and we'll see.
Okay.
Did you set directory?
Okay,
Did you set your
okay, I think I've got the problem is in setting the working directory.
Yes.
Let me repeat just the session of getting the setting the working directory. Okay. Okay, it is in my drive D. R Studio. And then data. Okay. Okay, now let me repeat the process. That is read.csv. Then for weight. .csv. Okay. And then we run it, and here it has brought the data on the weight A. I also want to do the same for weight B, which we're going to merge with that weight A. So before I can do that, probably I would like to first name this. For example, I want to call it weight A for easy dealing with the data. Weight A to be equals to all this information in this line 3. And then we run that so that it comes in the environment, and here is the information in the environment, which is this one. So weight A has all this data. Then I also do want to do the same for weight B. So we do the read command for weight B, or read.csv. In bracket weight B. And we run that too. So we have now the information for weight B already imported, and I would like to call it weight B. So weight B will be equals to this whole this command that we have put above here, which is having the information. We paste that. Okay. So when we run this, we also get the table for weight B, and here you can see the table for weight B. So these two tables, weight A and weight B, is they are all having a common column, which is for ID. The ID for both of them are the same, except for this other day and month, and then this one for A is sex, weight, height, and then the arm. So what we are going to do, we're going to merge the weight A and then the weight B using the merge command, and that is merge. We put what are we merging? We're trying to merge weight A and weight B, but using a common column, which is the ID. So we shall get the weight A, comma, weight B, comma, by equals to. So what this is what we are going to use, which is common between the two, which is the ID. And we run this. When we run, we find out that in this point, we do have ID common for all of them, for the two tables, weight A and weight B. And then the information has been merged for weight A, which ends up to here, and then for weight B, which is these two. So when we come to, okay, yeah, okay. If you want to view it, you can even name this something, and then we can view it from the environment in case you would like to see it too. or else we could go to the other type of merging, which is the left join merging, right join merging, and others when the information in the ID, for example, are not the same. So for this one, we have the ID, which is common for all of them. This is common for weight A, and then for weight, for weight B. Then for weight A, also this same ID is the same as the other one for weight B. But assuming, for example, in this ID column, there is a figure which is not the same as that in weight B. That could be a different case, and we don't use the same merge command, because this merge command is for when all of them are the same for this ID column. That's when we can merge it directly like that. So assuming we do have different data whereby they are not the same in this column for ID, then we have to use another format for merging. For example, in my data here, I do have some data that I've created for the two cases where we're going to use different kinds of merging. So let me read it because it is also in one of my documents. So let me import it. Actually, this one I've just saved it as an Excel sheet. So we import from Excel. It's in my desktop. This one is called table 1. I want to import that table 1 for using it for that illustration. And here it has come. Then I also import table 2, which is having the same data, same information, except for those two, for that column, which is having a difference. Table 2. So here we have table 1 and table 2. In this table 1, in this table 1, we do have ID ending from starting from A, B, C, D, and F. And in this other table 2, we have A, B, C, D, and E. So that's the difference. Here is E, and the other one is having F in it. So how do we merge those two? We cannot merge it directly the way we have been using the other merge command. So what we are going to do is using the left, either or left join or right join or full join or inner join. So let's start from the left join command. That is left join. Then we put table 1 that we have imported, table 1, comma, table 2, comma, then by equals to, we want to join, but they all have a common thing called ID, and we run that command. So you can see that in table 1 and table 2, the table, if we use this command, it means that we want it to include all the information in table 1 and also those in table 2, which are similar to those in table 1 by ID. So if we check in this in the console, we find that the ID which is common for all of them is A, B, C, D, only up to D. That's why the information there is all for all of them, for A and for table 1 and for table 2. However, for F, this is for F. This F was for table 1. Since it is including all the information in table 1, that's why we have the 9, the one which was for F. And NA, I don't know, this is not applicable. It was supposed to be for table 2, but since we had put it to start with table 1 and then table 2, it will only include those in table 1 and anything which is in table 2 but similar to that in table 1. The one which is not similar, which is in the other case was E, is being taken as the answer for it is NA, because it was not similar to the other one. So that is for left join. It will take the one in the left and then include all those in the right, which is this table 2, but similar to that in the left. Then we go to the right join. We also use this another command for right join. And then we put table 1, comma, table 2, comma, then by equals to ID, which is common for both the two. So when we run this, it's going to include all the information in table 2, but will include only those in table 1 that are similar to that in table 2, basing on the column of ID. So we also run this command and we see we view what it will bring in the console. So if you check the console here, we find that he has included all the information which was in table 2, which is up to this 29. But in table 1, for which is having this other one was having F, just like in this other first case. This 9 is missing because this F was not similar to E in the ID column, which is common for both the two. That's why this NA is here in this one. So then we also have the full join, where we are joining both the two tables. So we shall use the full join command, full join, and we get table 1, comma, and then we're joining it with table 2, still by ID. By ID, and then we run that. So it's going to join table 1 to table 2. And you can see that it has joined in the console here. We have table 1, information for table 1 and for table 2. This ID is common for both the two tables. However, it has now included all the two information. This NA is having a data which was different with the one for the other table 1. And this NA also the same, is having data which was similar, which was different from the one in table 2. And there you will have used the full join command to join both the two tables, though the information which was missing in either of the two, which was not similar, it will put it as a NA. Then we do have the inner join. Inner join is going to only join the two tables with information which are only similar. Those which are not similar, this NA will not appear in it anymore, because it's only going to pick the similarity based on that ID. So we have the inner join command. Inner join, then we will put that is for table 1. We're trying to join inner join table 1, comma. Sorry, table 1. Table 1 to table 2 by still the same thing by ID. So when we run this, it's going to bring for us only the information which is common for both of the two, basing on the ID column. So if you see the ID column A, B, C, D was similar for both table 1 and table 2, because they all had A, B, C, D. And their information were all outlined. The table 1, in A we had 5, and in the other one we had 30 until the end. So it has eliminated those which were not similar for the two cases, for the two tables. So by that we shall have learned the methods of joining them using the merge command. Thank you, Doctor.
Thank you very much, Rashid. That was a great job done. And we are happy that you're putting it in practice. I hope everybody tried and got some output. You managed to merge, because when we collect data from the field, you can go the first time, then the second time. So you have many worksheets and you want to merge them. So that's a good idea for you participants to learn how to merge data. So let's start off with today's work, and it's already shared in the Google link. I'm going to share what I have here. It's the same thing that you have. Rashid, you can stop sharing.
Okay.
Yes.
I would like to be helped, Doctor.
Yes.
Looks like my screen has frozen a little bit. If they add another, the admins could help me to remove me out. I mean to stop my screen.
Oh, okay. Dr. Runyararo, David, can you help and stop the screen? The screen is like frozen. He can't. I think it's now gone.
Oh, yeah.
Yeah, it's okay. It's okay. Let me share. You couldn't take off the screen, but now it's fine. Okay. Slide show ya kuweka wa.
From current slide up there.
Okay. Good morning, participants, and you're welcome to today's session. It's about exploratory data analysis, and we are going to be recapping what we did, but this time we are relating it to a data set, making it a live data analysis. We are first of all going to do theory. Then after some theory, we will do practicals. So if you have any question, you've not understood anything, please post it in the Q&A or in the chat. Thank you. So we find that exploratory data analysis is aimed at summarizing the main characteristics of data sets using either numerical or graphical methods. It is a very critical stage in analysis because it provides insight into data analysis. It provides insight into modeling and hypothesis testing. We find that when you get data from the field, you're so eager to see what is happening with your data. You want to find out if you are doing an experiment, whether the treatments had an effect on the response, if you're doing a survey, whether the community responded yes to the question that was so pertinent. If you're doing breeding, you want to find out whether this particular variety you're interested in is the one which came out. Those are the feelings that most of the scientists get when they get data and they want to analyze data. So in most cases, they skip this step of exploratory data analysis, but it is important in that from the exploratory data analysis, we are able to see a lot things that you didn't think about come up in the exploratory data analysis. We find that John Tukey encourages statisticians to do exploratory data analysis so that you can be able to formulate hypotheses that you may not be able to come up with as you do your proposal writing. So for example, if you are investigating some exotic varieties and indigenous varieties, but you never thought of actually comparing the within the exotic alone and within indigenous alone. But as you do your graphical methods and you do your numerical, you find that actually you need to compare the exotics alone and indigenous alone, and then go back and then look at the difference between exotic and indigenous. So the importance of exploratory data analysis is to maximize insight into a data set by uncovering underlying structure, which include relationships between variables. You will be able to extract important variables, create new variables, and also transform data. So that all comes out in the exploratory data analysis. You are able also to detect outliers and mistakes that you've done. So in most cases, you can enter your data in SPSS, or you enter your data using Excel, Microsoft Excel. And when you run some pivotal table in Microsoft Excel, or you do some cross tabulations in SPSS, you find that you've made some mistakes, especially where you've coded female 1 and male 0. The codes do not have any meaning. And you find instead of entering 1, you entered 10. Instead of entering 0, you entered 20. So those are the mistakes that you pick out when you do exploratory data analysis. Exploratory data analysis also helps us to fulfill the assumptions under statistical inference. Remember that most of these statistical inference, we assume the data is normally distributed. We also assume we have homogeneous variance among the residues. So we will see those terms as we look at experimental design or when we do regression. So when you do exploratory data analysis, you're able to know whether this data is skewed or it's symmetric. And if you find that the data is symmetric, which is normally distributed, then you know that that assumption of normality is valid, and now you can go ahead with your analysis. Sometimes you come up with hypotheses about the cause of an observed phenomena during an exploratory data analysis. And that you cannot pick out if you go straight into modeling. So sometimes, like I said, you have looked at the indigenous varieties and you also looked at the exotic, but your question was to compare indigenous and exotic. But you also find that the magnitude of the indigenous are higher. One indigenous is higher than the other, the mean yield, for example. And if you look at the exotics, there are also differences. So you want to find out these observed differences. Are they really statistically significant? So you can pick such things using exploratory data analysis. Or if you're doing surveys, you find that initially you said you're going to find out whether there is an association between the opinions of the communities and management of a neighboring natural resource, maybe minerals, maybe forests, maybe a national park, and you want to find out whether they really like the management, whether they are involved in managing the natural resource. So at first you thought of just analyzing it using a chi-square, but in the minute as you do the exploratory data analysis, you find out actually I could do a logistic regression and find out what factors influence a community to say that the management is either bad or good. So those are the things that come up. When we write our proposals, just from the word proposal, it's not exactly what you're going to do, but it's what you intend to do. So as you get your data, you actually either go with what you proposed or change, so long as the analysis goes hand in hand with the objectives, okay? So sometimes we find that when we do exploratory data analysis, we support the selection of appropriate statistical tools and techniques. So if you find that the average yield for the different varieties is standing out, there are differences. So you want to find out, are these differences statistically significant? Then you choose an analysis that suits. If you have only two groups, then we go for a two sample t-test. If you have more than two groups, then we choose analysis of variance. If we find that actually it is not the difference, but a relationship between these two variables, then we go for regression. You can see that the data that you've analyzed using exploratory data analysis helps you to choose the most appropriate statistical tool or technique for further confirmation of what you've observed in the descriptive stat that you've done, okay? It also provides us further basis for data collection through surveys or experiments. So assuming you've completed your data collection, the data answers actually your objectives, but you find that something has cropped up in your mind, but you didn't collect data about it. That becomes a recommendation at the end of your write-up. And it also forms a basis for somebody to do a survey or an experiment. So that's what happens with exploratory data analysis. So how do we choose the method of exploratory data analysis? Now, it depends on the data you have. Is the data numerical or not? If it's numerical, are you going to use, it depends on the method of summarization. Are you going to use numerical summaries or graphical summaries? With numerical summaries, we are talking about things like measures of spread. I hope you know these. Measures of spread include the variance, the standard deviation, or we are looking at measures of central tendency or measures of average. We are looking at the mean, the median, the mode, etc. And when we look at the graphical summaries or graphical methods, we are talking about a scatter diagram, a histogram, a box plot, I believe you guys have heard about all these ones, a box plot, a scatter diagram, but as we go ahead, under this theory, we'll be talking about those things. It also depends on the number of variables that are being examined and also the type of variable, okay? So if you have only one variable, you're going to analyze one variable at a time, you'll have a different type of analysis compared to when you have so many variables at a time. So you want to combine many variables at a time. So this is just a summary of what we are talking about. If you have a univariate, then you can either do non-graphical methods, which are the numerical summaries. And under that, you have measures of location. People call it location, others call it average. Other researchers call it measures of central tendency. So don't get confused with those terms. And examples include mean, median, mode, quartiles. Then measures of spread. We have range, variance, standard deviation, interquartile range, or you could use frequencies. But you can see that even these methods depend on the type of variable that you have. So we shall see that as we go ahead. We also have graphical methods that you can do. If you have one variable, you can draw a box plot, a histogram, a stem and leaf, a bar graph, a pie chart. The type of graphical method chosen also goes hand in hand with the type of variable. So when I talk about type of variable, I believe my colleague talked about it, that we have the major ones. We have the quantitative and qualitative. Then under quantitative, we have continuous and discrete. Under continuous, these are variables that are measured, for example, height, weight, distance, etc. And then discrete counts, number of birds, number of animals, number of participants attending data analysis using R. That's a discrete variable. So when you have a discrete variable, the way you draw a graphical method is different from when you have a continuous variable. So for continuous variables, as we shall see, we can use a box plot, we can use a histogram, we can use a bar graph, we can even use a bar chart and a pie chart. And then for a discrete variable, we can't use a histogram. Remember, if you're just counting numbers and then you construct a histogram, you're going to have spikes, corresponding to the different frequencies. For example, how many of them are 2, 3, like that. So in that case, we use a bar graph or a pie chart, and we must also summarize our discrete variable depending on the groups that you have within your data. Then when you have many variables, we call it multivariate, you can do a cross tabulation. I've already seen my colleague doing a cross tabulation of quality versus type of diamond. So you can see those are two categorical variables. If you have weight of diamond and quality, that is a combination of a continuous variable and a categorical variable. You can also do a cross tabulation, but in this case, instead of having counts, we are going to have means for that particular cross tabulation. We can do covariance, correlation, variance, covariance matrix. For graphical methods, if we have two variables, we can do a scatter plot, which helps us establish relationship between two variables. We can do bar graph, we can do a histogram, we can do box plot. We are going to see this in details as we go ahead. In the chat, can I see if I'm moving very fast or the speed is okay? So let me know, am I fast or not? Just say yes or no. Okay. 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 Some people are saying too fast. I'm going to reduce. Others are saying it's okay. So I'm going to get the average speed. since we are doing statistics. Okay, let's go to the next slide. Ooh. My. Okay. So the next slide talks about the description of the data set. You've already gotten this data set. The data set is called employee data. This is a data set that I got from the archive of SPSS. So if you go to SPSS, you'll find this data set, and it consists of variables like gender of employee, education level, job category, and under job category, there are 3 categories: current salary, beginning salary, time on job in months, previous experience in years, minority categorization, meaning yes or no. So before I move in the chart, can we identify the categorical variables in the chart? Can we see whether you can identify categorical variables? Just write it in the chart. So give you an example of categorical variable. Yes, I can see one of them is gender. Can I see a next one? Somebody says education. Job categories, great. Minority, great. That is great. Yes, thank you so much. Oh, somebody is saying variety, land cover. Okay, you are right. Land cover is categorical. Okay, thank you so much, participants. Yes, gender is categorical and has 2 categories, male and female. Job category is categorical. It has cleric, custodian, and manager. And minority is also categorical. The rest are not categorical. I want to ask one more question. Among the categorical variables, which ones are nominal and which ones are ordinal? Can I see in the chat? Just say gender, nominal. Minority, nominal, something like that. So let's see in the chat. Which ones are nominal and which ones are ordinal? Okay, great. That is great. Gender is nominal, and then minority is also, oh, okay. Okay, great. Thank you so much. Thank you, participants. Okay, so gender is nominal because these are names. There's no ordering on the names. The order does not matter. I can put female first and male second. Job categories, the order doesn't matter. And minority, yes, no, doesn't. The order doesn't matter. However, if we had things like temperature, then performance on job, then we would see things like good, very good, excellent, and poor, and then very poor. Then the order matters because there is a certain natural ordering that has been used to form those categories of performance. So I just wanted us to do a short recap and see whatever my colleague talked about, you've already picked, and I'm grateful that you're doing a good job. You're not just keeping the notes, but revising as well. Thank you. Okay, among these variables, can we see which ones are continuous? Among the variables that are left, which one are continuous? Just type in the chat. Okay, yes, I can see. Okay. Okay, great. Okay. Yes, okay, thank you, participants. That is great. The rest of the variables, educational level, it is number of years at school is continuous. Current salary is continuous. Beginning salary is continuous. Job, time on job is also continuous, and previous years. Thank you so much. So let's see the next one. So that is the data we are going to deal with. So assuming you've come out of the field and this is your data set, there is no way you're going to do confirmatory analysis without doing exploratory data analysis, because you actually don't know whether there are relationships between gender and birth date, between gender and years in school, between gender and any other variable. So the best thing here is look at the categorical variables, gender and job category. And then think, is there a relationship? So you run a cross tabulation, find out whether there's anything you can pick out. Run gender and current salary, or run job category and current salary. Find out, are there differences in the amount of money received by the different categories? Now, if you find the differences are there and you feel there are big differences, you want to find out, are these differences statistically significant? That is when the confirmatory tests come in, which are also called inferential statistics. So inferential statistics are also confirmatory. Why do they call them confirmatory? Because they confirm what you've observed in the exploratory data analysis. Okay. Okay, so now we are going to look at summarizing quantitative variable, one variable at a time. Okay. So in case you have a question, please put it in the chat. My colleagues will help me answer them. And after some time, I'll also be checking the chat. Those on YouTube can paste them in Q&A if possible, or you can send them to our hosts. Okay, so if you are summarizing a quantitative variable, we had a list of graphical methods. We could use a box plot. What is a box plot? It's a 5-number summary. What are those numbers? It consists of the minimum value. If you look at this box plot, there's the lower whisker, that is the minimum value. And as you move along the dotted line, you find the first edge of the box. It signifies the first quartile. Then we move in the middle. There's what we call median value. As we move to the next edge, we have the third quartile or upper hinge. As you move along the dotted line, you will find the maximum value. And then if you have outliers, they would be noted by dots along the box plot. So here, these dotted lines represent the whisker on the upper side, and we have a lower whisker. In the middle, we have the median. Now, if the distance between this side, the lower whisker to the median, is equal to the distance between the median and the upper whisker, then that data is symmetric and it is normally distributed. If one side is bigger than the other, then the data is skewed, depending on the side which is longer. If the right side is longer, which is the upper side of the whisker, then we would say the data is skewed to the right. If the left side is longer, the data would be skewed to the left. The difference between the first quartile, Q1, and Q3 is called interquartile range. Okay. And we know that median, it is a value that represents the middle position of your data after being arranged in ascending order. Yes, I think ascending order. Yeah. So that is what we call a 5-number summary. And with this 5-number summary, we can also know the distribution of your data. So within our data set, we've already identified the quantitative variables. We have educational level, the current salary, beginning salary, time on job, previous experience, all those are quantitative variables. Remember, I said under quantitative variables, we have continuous variables and discrete variables. So we can choose one of the variables and analyze. So we've chosen educational level. And how do you get the 5-number summary? You can either calculate them by hand or use the computer. Since we are in the computer outburst of knowledge, you know, there is excellence in knowledge as far as computing is concerned. We can only use manual calculation. If you're learning, it's always good to learn from first principles. How do we compute the minimum manually? How do we do it manually? You know, those first principles actually stick in your head. Then when you go to the computer, it flashes for you the minimum, the lower quartile, the median, the upper quartile, but you don't know how to calculate these things. So always remember that, learn how to do them manually. We won't do manual calculation now because we are online and we need extra accessories for us to do those things, and it may take us a bit longer. But this is, I'm just going to give you a homework. When you go back, please look at how they calculate the minimum, the lower quartile, the median, the upper quartile. The time when I did my statistics in 1997, that's when I did my MSc in statistics. We used to use actually manual calculation. Most of the computers were mainframe computers, huge computers. There were very few. So all these statistics we are teaching now, we used to do it manually. But I thank God that I was born in that time, because now things are easier than when you do things, you know, using the computer all the time. There's something you miss. So that's why I encourage you to go and do some manual calculation. Don't pick whatever the computer gives you, just take it wholehearted as gospel truth. Remember, if you make a mistake, the computer is also going to make a mistake. So always remember to do some manual calculation. So the 5-number summary, we talked of the minimum, the lower quartile, the median, the upper quartile, and the maximum. So beyond the maximum value, there is a formula here. You can see upper quartile plus 1.5 times interquartile range. So this Q3 plus 1.5 times the interquartile range gives you a value. And in case any data value is greater than this value you see here, then it is identified as an outlier. You see here, I'm naming them outliers if they are beyond this range here. Okay, so they come out to be outliers, and you can always confirm them using this, what we call the fence, the upper fence formula. It is the third quartile plus 1.5 times the interquartile range. It gives you a value. If within your data set, the values are higher than that value, then they are outliers on the upper side. Okay, so we see maximum values, but they end up to be outliers, and outliers, we shall also look at those ones later. We've also said that the interquartile range is the difference between the upper quartile and the lower quartile. And we also talked about the range is the difference between the maximum value and the minimum value. We've also said that the median value is the value that occupies the middle position of the data when it has been arranged in order. Okay. So after you've drawn a box plot, you have to write around it. If you're still a student, as most of you I saw are still students, don't draw a box plot and paste it in your Word document and leave it there for your supervisor to talk about. No, they are not going to help you. You have to write around it. So remember, whatever you put in your document, write around it. For example, here we are saying the least educated spent 8 years at school. That is the minimum number of years spent in school. And the most educated spent 21 years at school. So you can calculate what is now the highest degree attained. 21 years, I think this should be a PhD. Calculate from the time you started studying. If you spent 21 years in school, you should be having a PhD. Unless otherwise you spent your time doing short courses, that could be possible. And you have so many short courses. And then we have 75% spent less than 15 years. Okay. So you can write around, and those notes you're writing around actually are going to help you in confirming what you've observed in the exploratory data analysis. We've also picked out current salary and summarized it by drawing a box plot. And you can see the maximum value, the maximum salary is $135. The minimum is $15,750. The average, the median is 28,875. So you can write the least paid earns 15,750, the highest paid. And you also want to find out who is that one earning that much money and who is earning least and what type of job that do they do. Because now you're analyzing data, you should be focused in the data and wanting to tease out why these numbers, because the computer gives you numbers but does not explain why they are happening. So we have to tease our brain to see, but why? Who is getting 15,000, the lowest pay? And what type of job do they do? And who is earning less than 25%? Who is earning 75% below the minimum or below the upper quartile? So those are the things you ask yourself and go within the data, do more analysis to answer your questions. So as you do your projects, this is just a piece of advice, always have a notebook around you when you're doing analysis, when you're collecting data, have a notebook where you write those things, and then they will help you to explain, to do your discussion, okay? So outliers, we've been talking about outliers. They are called unusual, others call them extreme observations. Observations that are separated from the rest of the data set are called outliers. You need sometimes to explore the reason why you have unusual observations or outliers. They could be of interest. For example, if you look at height, there are some people who are really tall and some people are very short. Then you want to find out why they are very short and why they are very tall. Then you will find yourself going into genetics of that person. So it might be genetical that that person is too tall, okay? But if that is your project, then the information about genetics is going to help you explain about that outlier. And what do? We don't just delete the outlier, but in practice, you analyze your data with the outlier, then remove the outlier, analyze your data without the outlier, compare the results. Look at the parameters. The parameters, for example, is the mean tremendously decreasing when you remove the outlier? Is the median changing, or is the standard deviation changing? Look at those parameters. And if you think the difference between mean with outlier and mean without outlier is statistically significant, you can test those two using a two-sample t-test, then the outlier is a major thing. You need to consider it, leave it in the analysis, analyze the data. However, if you find that it's going to affect, for example, you're doing prediction and it's inflating the slope, yet actually the slope should be some magnitude, then you might have to remove it if it does not significantly affect the difference between the slope with outlier and without outlier. So you have to check and see what is happening to your data. Okay. So before we go to the description of the population distribution, let me go in the chat. Is the speed okay? Is there anybody who has a problem? Okay, great. Any problem? Anything that you need to be recapped? Okay, great. Thank you very much. Okay, let's go ahead. Population distribution characteristics are of interest because they help us to know whether our data is normally distributed or it is skewed. So we are interested in the center of the population. We are interested in the spread, which looks at the variability of the data. The center looks at the average value. How is the average value, the magnitude of the average value, how is it compared to the standard deviation or variance of the data? We look at the shape of the distribution, and also we can look at the outliers. So we remember that in our statistical classes, we know that the measure of central tendency are many. We have the mean, and the mean is the sum of all observations divided by the sample size. Sample size is n. And the mean is actually affected by extreme observations or outliers, because you're summing everything and then dividing by the total number of observations. So we find that when you have a data set which has very extreme observations, the mean may not be a good measure of central tendency. The median would be the best measure of central tendency because it's not affected by the outliers. Or sometimes instead of using the median, you can use the trimmed mean by excluding the extreme observations from, and then you calculate the mean and look at the difference between the mean with extreme observations and mean after removing the extreme observations. So let us examine what happens to the mean of current salary and the median. So we know that our measure of central tendency, they are median, mean, and then we have also trimmed mean. And the trimmed mean is computed after you've removed the extreme observations. In this table, we see that our mean is 34,420 before you remove the extreme observations. The median is 28,800. And then the trimmed mean after removing 80% of the extreme observations, it ends up to be almost similar to the median. And when the mean is equal to the median, then that data is normally distributed or it is symmetric. So this shows you how the extreme observations actually affect the magnitude of the mean, but does not affect the median. Okay. Then years at school, we find the average number of years is 13.49 months. The median is 12. After removing 92%, you find that the trimmed mean is 12.4, which is almost like the median. So this is just showing you that when you have extreme observations, pay attention to the value of the mean. And if you want to leave them in the data set, then median would be the best way of summarizing your central tendency. If we are looking at income and you want to report the average income of a country, you will find that some people actually in Uganda are earning 1,000 per day, yet there are those earning billions per day. So if you are looking at data per day, you will find that you're going to have a skewed conclusion of saying actually people are well off, yet the mean is affected by this person earning in billions. So when you have things like income, you're better off using the median, okay? Because it does not change with the presence or absence of extreme observations. Measures of spread. Spread is a measure of how far a value is from the central value. The central value is the mean. So how far is a value from the mean? And we have examples like the range, which is the difference between the maximum value and the minimum. Then we have interquartile range, which is the difference between upper quartile and lower quartile. So both range and interquartile range actually do not take into account all data values. You only use two values. So if we look at our box plot, you can see the range. You can also see the interquartile range. Okay. So if you've used the box plot as a method to present your data graphically, you can actually talk about the range and also the interquartile range. And then you also talk about the spread. So if you look at this box plot from the chart, is it symmetrical? Let me see from the chart. Is the box plot symmetrical? You say yes or no? Skewed. If you say skewed, is it skewed to the left or to the right? Okay, it's not symmetrical. Is it skewed to the left or to the right? Okay. Some people are saying left, some people are saying right. Okay. If you flip this box plot and put it horizontally, you will see that the longest tail is on the right side. And the shortest tail, this one, is on the left side. So when you flip it, the IQR is going to be the one like shouldering the box. And you see the longer tail is on the right and the shorter tail is on the left. Now, because the longer tail is on the right, the data is skewed to the right. So this is skewed to the right. Okay. So we also have other measures of spread. We have variance and standard deviation, and the formulas are there. Standard deviation is the square root of variance, and standard deviation carries the units of the variable being measured. So if the variable being measured is weight in kilograms, then the standard deviation value is also going to carry kilograms. Now, variance carries the square of the units. So this is very important when you're writing a manuscript, even your project. You can just present your standard deviation without your units, but I'm telling you, when you're publishing, you need the standard units. So if it comes to standard deviation, it carries the unit of the variable. The variance carries the square of that unit. So we'll have kilograms squared. That is the variance. Okay. So do extreme observations affect the variance, the range, and the standard deviation? Range, no, because it uses only two values. Interquartile range, it uses almost all the data because it's the difference between the first quartile and the third quartile. So it is affected by the outliers. The variance is and the standard deviation are not affected by the outliers. Okay, let's go on. Distribution. The shape of the distribution is important. We also want to know whether the histogram is peaked or not, or it has two peaks, which we call a bi. And then if it has one peak, it is one peak. So if we look at this, you can see that in this case here, we have a uniform distribution. And here we have a normal distribution. You can see that there is no, it's relatively symmetrical. We don't see any longer tail on any side. So let's see a clear picture. Shape of distribution. Symmetric distribution has one peak. Non-symmetric distribution also could have one peak or two peaks, depends. But when you look at our symmetric distribution, the left side, the left tail is equal to the right tail. So both have similar length. That gives us a symmetric distribution. Then when you look at non-symmetric, you can see the left side is shorter than the right side. So because the tail is long on the right, this data is skewed to the right. Let's see another picture. Left or negative skew. We see that the tail is long on the left side and shorter on the right. So this is a left skew or negative skew. And we've already seen the positive skew. It is just the opposite of the left skew. So when you get your data, please write. It has left skew. The tail is going to the right if your supervisor doesn't understand left skew, but most cases they are very knowledgeable in statistics. But you explain, write something. Don't just leave the graph hanging. Okay. In symmetric distribution, we find that the mean is similar to the median. They are almost equal. But in our data set here, the mean is actually bigger than the median. Here, after trimming of, we find this value here, 33,700, and then 33,900, almost similar. So both tails are similar length. We call that symmetrical. Negative skew. The median is greater than the mean because these are negative values. Okay, that's why you see it is longer on the left. When we talk about the right skew, the median is smaller than the mean. The median is smaller than the mean. So sometimes you don't need to draw all these graphs. You can have only descriptive statistics and use those values to talk about the distribution of the data. But if you think you need a histogram, then construct the histogram and relate it to the table also, okay? So we've been looking at summarizing a quantitative variable now. How do we summarize a qualitative variable? Now, the concepts of central tendency, spread, and skewness have no meaning for qualitative nominal variables. You see, we have gender, we have categories of employment. We cannot actually draw a histogram or a box plot for those variables. So those variables require some other type of summary. Okay. So we are unable to do minimum, maximum, things like that. We cannot do them for qualitative variables. So under our data set, we've identified that gender, job category, and minority are the categorical variables which fall under qualitative. So those variables are nominal in nature. And what can we use to summarize them? We can use frequency tables. So you pick a variable and get frequency values corresponding to the different categories. We can also draw a pie chart or a bar chart. And a bar chart is different from a histogram. They all have bars, which represents the frequency of each category. But in a histogram, you saw that the bars are connected to each other. In a bar graph, we are going to see that the bars stand alone. They represent their category, and there's some space, we go to another category. So here we are summarizing gender. And from the data set, we find that there are more male than female, because here, when you look at the relative frequency, you just need to multiply by 100% to get percentages. So we know that the female are 45.6% after multiplying by 100, and the male are 54.4%. So they are more male than the female employee. Okay. Then the same data can be represented as a bar chart, and you can see the bars. We have female red and male blue or green. Is it lime green? I think so. Lime green. Okay. So those bars are separated by some space, unlike in a histogram, which we saw. Yeah. Okay. Then we can also summarize another variable using either a pie chart or a bar graph. And we see that the highest number of employees are clerical. Those doing clerical work include the messengers, those who are typing, the secretaries, those are clerical work. Then custodial are those that guard your buildings throughout the night. The managers are the ones that make decisions. Okay, so we have fewer managers. There is a reason why we have fewer managers, and I think keep that, we will see it when we look at the salaries and job category. So the same information is represented as a bar chart, but in your projects, please present one of them. If you choose a bar chart, the bar chart will explain everything. Don't have a table and then a bar chart. No, only a bar chart will represent this information. Or if you choose to use a frequency table, that's good enough. Call it table 1, categories of employee in a certain company. Then if you have a bar graph, the title goes below. Just like you see bar graph. So categories of employee in a company, the title figure 1 goes below. On a table, the title goes on top. The pie chart, the title goes below. So any graphics you have, the title goes below the graphics. That is the standard way of publishing. Then the table, the title goes on top. And remember to refer to those titles. Figure 1, write around it and put in bracket figure 1. That's what you're talking about. Don't again label it properly, and then you start writing without referring to it. You have to refer to the graphs. We also look at minority classification. So non-minority are the majority, and then minority are very few. So you can either have again a table, either pie chart or a bar chart, one of them, not both, or not all. Okay. So we've looked at dealing with one variable, summarizing one variable, either qualitative or quantitative. And when you have qualitative variable, the descriptive way of presenting data is percentages. So you have your frequency table here, multiply this relative frequency by 100, and you form your percentages. Then you write around them, say 78.1% and non-minority. So they are more, they are less minority in the company, and most of the people in the company are the non-minority. Okay, so you write around it. So you see that we've not gotten the average minority or the standard deviation of minority. Doesn't make sense. So that is where we started from, that the type of variable determines the type of statistics you're going to apply to the variable. So when you're writing a proposal, you know actually the type of variables you're going to collect, and you can write the statistical methods you're going to use, even the inferential statistics. And when you come back with your data set, you just add on to what you proposed in your proposal. Remember that if you know how to analyze your data, you're going to complete on time. If it's 2 years, it will be 2 years of master's. If it's 3 years of PhD, it will be 3 years. So long as you dedicate time. Because some people want to be perpetual students. They keep working, they don't give time to their PhD or their master's, so they end up spending 10 years doing master's. That's not so good, okay? Even for your children, how will you tell them you spent 10 years doing? What reason? That is just a commercial break. Let us go to relationships. Sometimes we want to establish a relationship between two variables. And how can we do that? We can look at relationship between a quantitative variable and a qualitative variable. So we can use a box plot, we can use a bar chart. Now, receive. If you're going to construct a bar chart using a categorical variable, in this case, we are not going to change the continuous variable into percentages. What we are going to do is calculate the means, then summarize the means by category. Or you summarize your data by the category, get the means, then you construct a bar graph. So don't go changing your continuous data into some groups and then you form frequencies for you to construct a bar chart. No, now here we can use the average values for each category to construct the bar chart. And even when you're going to collect data, if you're going to collect data, especially people doing surveys, age, leave it as it is. Don't classify age before you collect your data. You can always code your variable age or income. Go and collect the raw data, get the real income. Then when you come back to analyze, you can record in those classes you want, but you have the real data. That data is important for modeling, but the classes limit the modeling. So remember, when you go to the field, ask the person the real age. If they don't want to tell you the age, just ask them when they were born. Then they will tell you, they will tell you if they don't lie. They will tell you they were born in 1900 or or 19 something. Okay, so then you are able to calculate the age of that person. So it's very important to have the real data when you're collecting your data and categorize it afterwards. Okay, so that is a caution, especially for people doing surveys. People doing experiments, they collect raw data and then categorize it later on. Okay, so we can now establish relationships between a qualitative variable and a quantitative variable using a box plot. So we can draw a box plot of salary versus the category, or we can have salary versus the employment category. And we can see that here, these I think of, okay, we will look. So we will look at, if we look at salary and employee, the different types, we want to establish whether there's a relationship between the current salary and employment category. So we have a summary statistics for current salary by job category. We have the minimum, the first quartile, the median, the mean, the third quartile, and the maximum value. So by the look of these three things, are there differences? Do we see any particular difference? Okay, there we go. So I wanted us to see whether cleric, we can see cleric earns 15.75. You remember we talked about that's the minimum. So the person who was earning the minimum's current salary was a cleric, and custodian is earning something like 24,000. These tables have merged, but the manager was earning more. But if you look at the education, number of years spent in school, who spends more years in school is the manager compared to the custodian and the cleric. So can we conclude that the number of years you spend in school determines how much you earn? Those are the questions that come up when you're analyzing data. Should we correlate education level in years to current salary? Are people staying longer in school earning more than those who are not staying longer in school? That one is a question for investigation. Okay. So here we have current salary and we have manager is the first box. We have clerical, and then we have custodian in the middle line, this middle line, if you see the cursor, and then the clerical. So we can see clearly that the manager earns actually more than the custodial and clerical, but the clerical earns less than the custodial. Number of years spent in school, you can see the manager has spent more years in school compared to clerical. Now, when you're presenting this summary statistics, choose either you want to present a table or you want to use a graph. And we can also look at the distribution of the data. You can see now the box is drawn horizontally. We see that the right side actually for manager is longer than the left side. So the data for manager is skewed to the right. When we come to clerical, it is because of the scale that it is showing this. When we look at clerical, it's also skewed to the right. And when we expand clerical, we'll look at that later when we are doing practicals and see whether it is actually skewed or not. But we can see that data for manager is skewed to the right and also for clerical. And we can see these points moving, which are far from the maximum value. We can also find out whether they are outliers. Now, when we go to years at school, for manager, is it skewed to the left or right? Let me see in the chart. Is the box plot for manager skewed to the left or right? Let me see in the chart. Okay, great. It is skewed to the left. That is great. Wow. Wow. You know, when a teacher teaches and people are getting things, she starts being excited. You are exciting me. I'm getting too excited. But this is a very good group of participants. They are very active and very attentive. When we look at custodial, is it to the left also? Let me see in the chat, custodial. Is it to the left? Custodial is to the right. Great. Wow. Ooh. Okay. And lastly, clerical, what do we say? The median is right here at the edge where you should find the minimum values where the median is. Is it skewed to the right or left? Let me see in the chat. Okay. Okay, okay, let me give more info. The clerical, the dark line you see is the median value, meaning the median and the minimum value are almost, no, they are not set, the median and the first quartile. So for the data to be skewed, the line has to be in the middle of the box. And this side should be equal, to be symmetrical. This side should be equal to this side. Now here we have, this other side starts from here and goes here. This is the left side. The right starts from the median and goes this way. I think they are not equal. This side is a bit longer than this side. So it's skewed to the right too. It seems, it appears like a bit symmetrical, but not really. Okay. So here is a question. Can education explain the differences in salaries for the different job categories? Is it because of education that they are getting, the managers are getting better salary compared to the clerics? So that is food for thought. Let's go to the next slide. There are some coefficient of variation attached. Okay. So we are now teasing our data out. We've decided to have managers alone, and we are analyzing data for managers by gender instead of all the data. We want to find out, under manager, are males earning better than the female? I think so. What do you think? Let me see in the chat. Are males earning better than the females? It says yes, yes, yes. And what is the reason? Somebody is saying no. That should be a lady. Okay, yes. Thank you. Gender. The reason is gender. Okay, when you look at this graph of current salary, the males are earning higher than the female managers. Let's also look at education. Are the female more highly educated than the female? It is also showing us in these two graphs that the males are more highly educated than the female. And then shouldn't we now conclude that actually the higher the level of education, the better the salary? Because even when we've teased out and looked at managers alone, we are seeing that the males are highly educated. They are the ones earning better compared to the female. They also spend more years at school. So you can see with one data set, you can actually answer so many questions. So many things come up just looking at the graphs. You haven't done any modeling. You're looking at the graphs and you can write paragraphs of information about descriptive statistics. So we are looking at salaries for clerical and education level in years. So for under clerical, we see that the males are earning better than the female, and even they are highly educated compared to the female. Is it true that even the clerics, the female, are less educated than the male? This is what the data says. But in reality, I don't know. Isn't there any form of discrimination here? Let's think about it. these companies are managed by males. Of course, they are going to employ more of the males than females at those top levels. I'm not being feminist, but I'm thinking loud like a statistician. Okay, what do you think, ladies and gentlemen? We saw that under managers, the males were earning better than the female. Education for males is higher than that of female. Even when we come to clerics, the same story. So what is behind this story? What causes the female having less education than the males? And is that the same thing explaining the females earning less money than the males? Let me see in the chat. What do you say? Just write a sentence. Okay. We have to know the study area. Okay. Study area, inequality, social roles, depends on the country, segregation. Wow. Few females who are educated, negotiation skills. Wow. This is perfect. Somebody brought smileys, emoji of a smiley. Yeah. Empowerment, gender policies. I think this data was collected. I will look at the archive. It seems this data was collected before they started the gender policies of encouraging more female than male in companies. The country, I think this is USA. I don't know the company, but the data comes from USA. Don't again quote me and say that in USA they pay more the male than the female. I don't know the current status now. So this is just data we've collected from SPSS, and we need to know when it was collected. Probably the story has changed. That's why we do research. But this is telling us that descriptive stat can do a lot. You can get a lot of insight in this. And we see that there are many things that can actually explain why the male are earning better than the female. Social roles, that is one of them. You find that females drop out of school because some of them get married at an early age. Some of them do not have, actually, long ago, they used to prefer to educate males compared to females. So the females would be left at home. They grow at an age of 12 and they are married off. So few female actually used to be educated long ago. But now, I think there is gender equality. You can find that in a company, the manager, the top manager is a female, and there are fewer male managers. So the story has changed, but this story here is telling us otherwise. So that's now research. That's what research does. You have to write the story as it appears in your data and explain to the world why there is this type of differences. Okay. So we can go ahead and look at things like the distribution of two variables together, which is called joint distribution. We look at the job category and also look at gender as well. Is there a relationship between gender and job category? Is there an association between gender and job category? When I talk about association, I think most of you now have tuned to chi-square, isn't it? Should be. Even me, I thought of chi-square actually. When I saw association, I thought, wow, we could do a chi-square here. But we could also do something also better. Are males and females equally distributed in the different job categories? Those are questions that you ask yourself when you're analyzing data. So when you get a data set, first tease it out with exploratory data analysis for you to be able to get good results, okay? So we are now going to look at the joint distribution of two qualitative variables, category gender versus job category, okay? So we can find out in each job category, are males equally distributed? If we look at the second part, this one has counts, and you can see there are no female who are custodial, and the custodial are very few, because normally in a building we have 2 or 1 custodial in the night or during day. And then the manager, female managers are fewer than the male managers. Okay, So if we convert this into proportions or relative frequency, we can see that they are more clerical females than males. That is expected. You see that most of the secretaries are female as compared to male. And even when you go to the hospitals, you find more nurses, female nurses compared to male nurses. And now the demand is high for male nurses from what I've seen, and the males are also joining the nursing job. Okay. So we are just looking at the joint distribution of job category and gender. You could use a crosstab, or you can do a bar chart. And we can see here that under the female, they are more clerical compared to the manager and no custodian. And when we go to the male, they are more clerical, fewer managers, and fewer custodial. I think that is true, that the custodial normally are few. We can also look at the totals. When you use a crosstab, you have what we call marginal totals. You can see these are the marginal totals for job category, and below here we have the marginal totals for the gender. So we can now look at how the gender is distributed across male and female, which we've already talked about. And we've already seen that the female are more occupying the job of clerical compared to the male, and there are no custodial female, but the males are the ones taking up the jobs of custodial, and manager, there are far less manager who are female as compared to the male. So this is the data. You are writing around it, and afterwards you're going to discuss in your discussion section why the male are more custodial and we have no female custodial. So you see that you can present the same data as a graph. You can present it as a table, as we saw, but present only once, only one thing at a go. So here, when we look at this, the crosstab and the graphs, we want to find out, is job category independent? I mean, is gender independent of the job category? So I want to find out whether there's dependency between those two variables. We cannot find that out using exploratory analysis. We'll do a chi-square test to find out whether there's an association between gender and job category. So that comes under confirming what you've already observed in the exploratory data analysis. So you can see that now you're actually determining the type of inferential statistics you're going to apply to your data using the exploratory data analysis. So we've been looking at qualitative variables. How about the quantitative variables? Is there a relationship between number of years and current salary? Does the current salary depend on beginning salary? Does current salary depend on previous experience? Those are questions that come up when you've collected data and you're analyzing, or even before, because you know actually the variables you're going to collect, and you have already written these questions among the questions you have in your proposal. Okay. So what exploratory data analysis can we use for such relationships? We use a scatter plot, okay? And a scatter plot, we have one variable on the x-axis and the other variable on the y-axis. The independent variable or explanatory variable is normally placed on the horizontal. And then the Y one is, which is also called an outcome dependent variable response, depending on the software you're using, goes on to the vertical axis. Why do they call it independent? Some theories of statistics think that the x-axis is measured with minimal error, while the Y value, I mean the Y variable is measured with, X variable is measured with minimal error, That's why it's called independent. It doesn't depend on any other variable to change. Meanwhile, the y variable, which is an outcome or independent variable, is going to depend on the values of the x to change of the x variable. That's why it's called depending. It is depending on something. Okay. So we can construct a scatter diagram. Here, this is a relationship between education and current salary. Is there a relationship? Can I see in the chart? Is there a relationship between current salary and years in education? Yes. What type of relationship, if it's there? You can say yes, curvilinear, yes, linear, whatever you know. Okay, somebody says positive relationship, linear. Okay, great. That is great. So there is a positive linear relationship between current salary and years in education. So let's see next. So here we are just highlighting the values that most likely look like outliers. And you remember, you can always test them to confirm whether they are outliers. And when you remove them, how do they affect the parameters of your relationship? Okay. Beginning salary versus current salary. What do we observe in the chart? What do you see? What relationship is there between beginning salary and current salary? What relationship? Can I see in the chart? Linear, is it positive? Is it negative? Positive. Okay, great. Wow. Yes. Wow, thank you so much. That is great. So it is a positive linear relationship. Why? Because you can see that if we drew a line, the values of current salary are increasing as the values of beginning salary increase. But remember, this is just a scatter diagram. We don't infer anything about this relationship. We just know there is a positive linear relationship and it appears strong. How do we know? If we draw a line through this point here, the 0, 0 point, and it goes exactly in the middle here, then we know that actually the correlation between current salary and beginning salary is closer to 1. Because this point here, if values go through the 0, 0 point, and they are concentrated along that line, then they have a perfect correlation, which is equal to 1. But here, we see that it is not going through the 0, 0 point, but it is close. So there is a strong positive relationship, linear relationship between current salary and beginning salary. You can also look at the concentration of points around the line, the imaginary line you are imagining, and that also tells you how strong the relationship is. So again, in the scatter diagram, you're able to identify the values that appear to be outliers, and they can be confirmed later using that formula of fences we saw. We can draw multiple scatter plots for all variables. Here we have current salary on top. So the top row is current salary. Then, wait a minute. Yes, the second row is beginning salary. This one is years in education. Then we have previous experience and time on job. So if we look at this one, the second graph on the top row, it's a graph between current salary and beginning salary. When we move to the third graph, it's a current salary versus years in education. So you go ahead, current salary versus time on job. You can see, what can we talk about this graph? Is there a relationship? That is the fourth graph. It is the relationship between current salary and job, time on job. Is there a relationship? Should we say that the time on job determines your current salary? So let me see in the chat. What do you say? You say yes or no? No, 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 no. Great. That is good. Okay. Wow. So we see that actually there is no relationship between current salary and time on job. So we'll go ahead and confirm whether it's true that there's no relationship. We can run a regression between current salary and all these variables to confirm this relationship we are seeing. When we looked at two categorical variables, job category and gender, we said we wanted to see whether one category is dependent on the other. And we could run a chi-square test of independence. So also when we look at previous salary, previous experience and current salary, we see a relationship which is very weak. You can see if you try to draw a line here, the data is far away from the line, which doesn't show that the relationship is there, but seems to be weak. So that's how you talk about the graphs that you draw. You go graph by graph, can draw them in one panel, and this reduces the number of pages you're going to have in your project. Instead of having 100, you may end up having 70. It's easier for people to read a smaller book than a big book, okay? And you don't need to talk a lot. Don't repeat yourself when you're writing your project. Okay, so that is scatter plot, multiple scatter plots. And here you can divide your data into female, male, and also draw the same scatter plots. This one's for male. We have seen clerical. This is current salary and beginning. You can see the type of graph we have. The story seems to be the same. I'm moving faster here because I want us to go do practicals. Then we have correlation and covariance. Covariance is a measure of how far two variables covary, i.e., how much and in what direction should we expect one variable to change when the other is changed. That is the covariance. Okay. Correlation is a standard measure of the relationship between two variables, and it's noted as small r. And there are formulas there. It ranges from minus to positive. So if you have one, irrespective of whether positive or negative, we call that perfect correlation. Okay, so there we go. And here, beginning salary versus current salary has a correlation value of 0.88. Okay, so is that strong correlation? Let me see in the chart. Is 0.88 strong correlation or it is weak? That is strong correlation because we've already said that it ranges from -1 to +1. Okay. So you could also draw multiple graphs and attach your correlations on them, and you can discuss the relationship between the two variables, and it also is showing the correlation. Where you see one, that is perfect correlation, and it's a relationship between beginning salary and beginning salary. So a relationship between those two variables gives you a perfect, doesn't have any meaning. We are interested in current salary and beginning salary. We are interested in current salary and years in school. You can see it is 0.66. And we are interested in the relationship between beginning salary and time on job, which is 0.08. That's why the graph appeared like the way you see it on top here. The fourth graph had a weak relationship between current salary and time on job. You can see when the correlation value is 0.084. So you will see that what you're talking about actually is also what the correlation is showing you in the graphs. So this is a table of correlation between current salary and other variables. So you can also draw such a table in your project or in your manuscript or in your report and start discussing for each category. So here, the first column here is combined. Then for manager, current salary and beginning salary is 0.69. Education is 0.39. As you go ahead, the correlations are becoming weaker. So if we establish that there is a relationship for some variables which is strong and others weak, we want to find out, is that type of relationship linear or nonlinear or curvilinear? So we go ahead and do regression. We can do either simple linear, two variables, the response and the independent variable. We can do multiple regression, which is one response and many independent variables. We can do multivariate, where you have many responses versus many independent variable. We can now turn the tables and say this relationship wasn't linear, it's curvilinear, and you do either quadratic or cubic relationship. You can also go ahead and say, no, I'm seeing a nonlinear relationship. So you could do a logistic, you can do, there are so many. So that's how we actually determine what type of relationship we are going to perform. And we also see that the values of correlation, they are related to something we are going to see when we are doing regression, which we call coefficient of determination, which talks about the amount of variability explained in the response by doing a regression with the independent variable. So if you do a regression of current salary and beginning salary, this value here, if you square it, 0.88 squared gives you that value of coefficient of determination. So that is mentioned in passing. When we go to regression, we'll be able to see all those things coming up. So that ends our theory. Let's turn to R, and you already have a script with you. So do you need a break? I thought this was just theory. Let me see in the chat. Do you need a break? Oh, they are saying, no. Some are saying, thank you. Yes. Okay, let me give you 10 minutes break. 10 minutes break. And, oh, no, not 20. That's too much. 10 minutes break. And let's come back at, no, it is 3:58. 50. Okay, it is 3:53. So if it's 10 minutes, then you come back at 4:07. 7 minutes past 4, please come back and we go to do practical. So when you come back, open R. And in case you have any question, post it in the chat. But I am so excited and overwhelmed by the level of participation and the level of knowledge you know in exploratory data analysis. Thank you so much for your attention. Let me see you in 10 minutes time. Okay, bye-bye. Thank you. Okay. Wow. David? Yeah, thank you so much, Dr. Nyararo. I think participants are back. We are switching to R. So please go and open the script called EDA, just an abbreviation for Exploratory Data Analysis. And I'm also switching to R now. Please switch to R. Switch to R. The script is called EDA, and it's among the materials we sent you. Okay. Switch to R. Okay, so in the chat, do you all have the script open? Can you say yes? Please mute the sound. The sound has been muted. So yes, if you already say yes. Materials are found in the Google link. Day 1 folder, but you'll see another folder named Day 3. Yeah? On top of Day 1 folder, that's what I'm told. If you go in the Google link, I'll request my colleague, Dr. Helen, to share the link again. Some people haven't received the link, unable to register due to browser problem. That when I send it to Amitu, yeah, there is the link. Thank you, Dr. Nyararo, for the link. Please click the link. You will get the data. And let us start. I don't want us to be left behind. Okay. Just EDA. Yes, yes, just EDA. Okay. Okay, so I'm going to start. Please share the registration forms. Dr. Nyararo is going to send the registration forms. Which format is this file? R. We are turning to R. We are turning to R. The registration form has been shared. So if you haven't registered, please do so for the benefit of all of us, you, me, and the funders. Okay, thank you very much. So let's start. From what we've learned the last 2 days is that in case you see that there's any package that you have, that you don't have among the list from line 2 to line 9, if there's anything you don't have, install. Please pay attention. I'm saying if you don't have any of these, Tidyverse, Learner R, Read Excel, Read R, Dplyr, Plotrix, AP Display, Gplot, if you don't have any, I'll give people 2 minutes to install only those they don't have. Don't highlight everything and install if you already have those packages, okay? So this is just caution. Look through the list and just highlight. For example, I can highlight ggplot2 and then click install. Then once it is installed, the next step we are going to is to load those packages. So the next step is loading the installed packages. Remember, please don't install the packages if you already have installed them. You'll spend more time waiting for the computer to do all that needful. So highlight them. Sorry, highlight. Don't look at mine. In case you don't highlight everything, highlight up to AP Display. You can see there is a GGP UBR used to create graphics, ggplot, data visualization, then AP Display displays graphs in horizontal, Plotrix in 3D. This one reads the CFS files, and you have the one which reads Excel files. So let's only use those ones that I have shown. So I'm going to highlight. I will use to be highlight. You can skip Gigi Pub, but if you need it, we will see whether we need it, we can install it later. So if you run, it's going to install. Like me, most of these packages and more that you haven't seen are installed on this computer. So when you run, you will see some reds, but they are not really messages that you should worry about. It's just telling you one package is masked under the other one, and that's it. If it says package does not exist, you know that one is not in your computer and you need to install it. So can we move on to the next step in the chart? Can we move on to the next chat? Mine is just blank. What is blank, my dear? The script should have some written information. Just a minute. That script is the same one I'm using. Mwalimu Rashid, your minute is over, 60 seconds are over. Okay, so it appears like you are ready. How do I install? Uh-oh. At this time, ladies and gentlemen, we did that for the 2 days. We gave you those 2 days so that you can learn how to install. Nevertheless, I have written the instructions in the line 2 up to 9. If you've not installed this package, just highlight them and click run. They are going to be installed. You need some like 5 minutes to be installed. After they've been installed, then you load the packages. So the installation, you have to be connected to the internet because it's obtained from the Crank project that is in charge of R. Okay, so you need to be linked. Once you've installed them, then you can go to loading. Loading, you highlight, you can write library in bracket, tidyverse, and then you run that and they'll be loaded. Okay, so I'm assuming we're okay. We are going to set our working directory. This is the folder where you've placed your day 3 information. That is the folder we are going to set our working directory to. So if you can observe what I'm doing, I go to session window, then set working directorate, and then choose working directorate. So those are the 3 steps I've gone to. Session window on the menu of the RStudio. Under that, we have set working directorate and then choose working directorate. So when you're there, click choose working directorate. Are we there? So let me open the chat and see if I'm leaving anybody. Okay. Okay, then after that, browse to your folder. You can see here, my folder is called day 3. I can first of all click to SDM and get day 3. Then I click open. That is setting your working directorate. Oh, I've done it twice. I'm going to redo it. So set session, set working directorate, choose working directorate, then, oh my goodness. There we are, day 3. Okay. Okay, in case you don't want to go through the menu bar, you can copy the link and paste it in the script in the RStudio and run, it will run. Okay. You've been left with your Misho, Justus, better run because we've already done this so far. So please put in more effort to find me. The things that I'm doing, we've already done them. Can you please clear the console? Fine. We see the brush here on your right under console. I've cleared my console. Okay, great. Okay, so the next thing we are going to import the employee data. The one we've been using in our theory is what we are going to use for our practicals. So just run line 31. And then once you see there's no mistake, please run line 32 also. So I remember my colleague said that if you are importing a CSV file, you use read.csv. If it's Excel, then the matter changes to read.excel, you know? And head is used to see the first 6 rows of your data set. Sometimes you want to see only 3, so you can put comma 3. So it shows you the first 3 rows. So once you've imported your data, print it out to see is it that exact data that you need. Once that is true, we are going to the next session. The session has already started, Liz, and I just want to know that we are all at the same page. So have you successfully imported your data in the chat? Have you successfully imported the data? Okay. I can see 1 no, 2 no's, 3 no's, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Ladies and gentlemen, we did this yesterday and the other day. Somebody is saying I repeat the process. The person saying I repeat the process, can you explain why you want me to repeat the process? Yet you've been here 2 days. Okay, I'm going, for the sake of this session, I'm repeating the process. 2 minutes, keep your eyes on the screen. Okay, let me go back. The first thing I said, if you do not have the packages listed, Frank, I'm repeating, pay attention. If you do not have the packages I've listed, highlight them like the way you see highlighted. Okay, if you do not have them, then click run. They will be installed, but you need to be connected to the internet. Okay. Oh, somebody says you are too fast. Okay, I am reducing the speed. That one is quite okay. So if you do not have the packages, highlight the command install.packages, ggplot2, and run. Once it runs successfully, it can take 5 minutes. Then you load. How do we load? The information is below. From line 12 to line 19, just highlight them and again run. Because I'm not running because I've already installed them. So once you run them, first they will allow you to import the data. Once you load the packages, you'll be able to import, you'll be able to draw graphs. Okay, fine. I do not have the run option. Okay, when you are in the R Studio, if you can look at the menu, the top we have file and all that. Go below, you will see the name EDA. Below EDA, you will see source on save. Then you will see a zoom button. Then you see another button called code tool. Then from there, you're going to see run. It has a green button, run, and it has the word run. Then you run. Or somebody is saying that actually here under run, they are saying Control Enter can do the same thing. So if you don't see it, just do Control Enter. Thank you very much. And I think that we finished that section. Let us go to setting the directorate. We said if you want to set the directory, go to the session window, set working directorate, follow the instructions, please. Choose the directorate. Once you are there, click choose, then browse to where your data is saved, and then you set your working directorate. The reason why I'm not doing it, I've already done it. So once you're there, What we are going to do is we are going to import. Line 31 says import the data. It is employee, is the object name, is the name I've given my data. Assign read.csv in bracket employee.csv. So run that, please. Okay, and then run head. It will show you the first 6 rows of your data set. Okay. So once you have the data, we are going to go ahead. I believe that everybody now has the data. Is that true? Can you say yes, 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 or no, 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 no? This time, if the no's are less than 5, we continue. Okay. Okay, 1 no, 2, 3, 4. Great. Okay, let's continue. Okay, let's go to line 38. It is the same thing. Head gives the first 6 rows. Here I'm just explaining. No, still stuck. What are you stuck on? Can somebody please write your problem in the chat? And also we need diamond data. Oh my goodness, we are not dealing with diamond data. We are dealing with employee data. Employee data is in day 3. My data is different. Which one did you? Okay, can you please put, Ellie is just laughing at me. It's true, you should laugh at me. Okay, ladies and gentlemen, let us now mean business. If you have a problem, write the problem in the chat. My 2 colleagues will help you. And also Q&A. The questions remain there for a long time. So where do I get employee data? Please, it is in day 3. Okay. Okay. Maurice, I hope you're fine. I can see emoji with the tears. I don't know why. I believe you're fine. Please link to the download employee. The link to the download employee has been posted, but my colleague will post it again. There you are. There it is. We used diamond yesterday. Today we are using employee. Please turn your mind to employee data. That's what we are going to use. I want us to do the practicals. I want you to finish today so that tomorrow we have something nice, even nicer than what we are doing. We want you to gain more knowledge in R. But if you dilly-dally and take more time on these simple things, you won't get the nitty-gritty of statistics. You see? Okay, now I'm going to go ahead. Should I go ahead? Okay. So some of you have problems. My colleagues will help you as we go ahead. Okay, head. Head, I've just said, gives you the first 6 rows of your data. You use it to view your data, to know that the data actually you've imported is the correct data. Then str, yesterday they told you to describe the structure. It shows you the scale of measurement. So we can run str for this data and it gives you lots of things. We can see the data frame consists of 474 observations and 10 variables. IDs, interval. It tells you gender is character, birthday is character. So that's what you see from your data. And then head, you can actually see the first 3 rows if you don't want 6 by putting comma, employee, comma, 3. So there you are. If you run line 43, you will see that you are only seeing the first 3 rows. Okay. Then when we go to class, employee just tells us the structure, that it is a data frame, and it consists of several variables. N row is the number of rows. I believe my colleague covered this. N column is the number of columns. So you can just run all this and DIM shows the number of rows and number of columns together. So I'm just running line 52 because of time. And you see it is showing that the vector length is you have 474 rows and 10 columns, with the 10 columns corresponding to the number of variables you have in the data set. Then column names is important. Every time you're analyzing data, please know how they are written. Are they lower caps or upper cap? So look at those names. Then row names just gives you the values. Okay. So you can see if you run row names, you get the data, the names, that is the number of the row, okay, displayed. So I'm going to clear this and let's go to descriptive statistics. So in the chart, we are moving to descriptive statistics. Are we fine? Okay, great. Okay. Okay. Edith, you're not fine. Okay, fine. So people are fine. We are going to continue. If it so happens, oh, you are so fast. Oh, sorry. I am going to reduce the speed. I am very, very sorry. Okay, let's go to descriptive stat. And under descriptive, we are going to give an opportunity to whoever says they are not fine to present the screen and we see what they are doing. Okay, and the speed, I am going to put a speed limit on it. If it has been 100, it's going to cut to 60. Okay, descriptive stat. Remember, under descriptive stats, we want to look at the measure of central tendency consisting of the mean, median, mode, and then we have measures of variability consisting of range, interquartile range, variance, etc. We could also look at frequencies. So if you want to summarize all your data at a go, now remember we have categorical variables and continuous, but we've decided to summarize all the data at a go. We use line 66, which shows summary in bracket employee. Remember, employee is the name we gave to our object when we were importing our data. So go to line 66 and run. So you can see that it has given you the summary of all other things, except it shows you that gender is a character. It's not going to do descriptive statistics for characters. You see, even R is bright. It does not give you garbage in. Yes, I can hear somebody.
Can you allow Mary Gachi to share?
Okay. David or Dr. Nyararo, can you allow, give her a right to share? So let me stop sharing.
We are promoted here.
Okay, Mary, please share.
Mary, you can now share your screen.
Good evening. Good evening.
Good evening, we can hear you.
I downloaded the day 3 material even before the class. I did download, but when I've set my working directorate, as you can see, and then the employee, when I run this, I get this error severally, and I don't know how to correct this error.
how was it saved? Did you check how the data set was saved?
Yes, I checked, and it's
Yeah, you check. No, are you in the right directory?
Yes, I'm in the right directorate. It is at, let me open. It is at.
And can you go to sessions? Try to reset it and we see.
Pardon?
Go to session, try to reset it and we see.
Just a minute. I have so many screens have opened. I need to minimize.
No, you have the screen of the sessions, the RStudio screen.
Yeah.
Go to sessions.
Just a minute. I don't know how do I bring this Zoom panel at the bottom?
No, but we are seeing your screen. There's the RStudio screen. Okay.
Okay.
Yeah, you go to session.
You go to the top menu.
Session.
Yeah, where there's session.
Yes, I've clicked session.
Okay,
Set working director.
Choose the
Yes,
working
click the
director.
session.
Yeah, I've seen it. Yeah.
Choose. Yeah. So can you click on that? And then, no, don't open it. Go back.
Oh, okay.
Just click on it.
Okay,
and then
it's that. Do I click again? Do I see? I feel.
What are there file inside there? Are there some
There's another
folders?
Yes, there's another folder. This is the second one.
Okay.
That? Can you see?
Okay. Then you click open. The open from down. Okay. Can you try now to? Okay.
Yeah, I have no error there. So when I come to running employee read CSV, and then I run, oh, it's working now.
Yes, because you did not go in and out. You stop at the upper part.
Yes, yeah, I think that was the problem.
Okay.
Thank you.
Okay. Can you now we'll just continue, others will follow. Okay, so let's continue. We were talking about summary statistics, and if you look at the console, you find that the internet went off. Let me load, share the script again. Okay, there you go. Is it visible to everybody, the screen of R?
Yes, yes.
Yeah.
Okay, thank you. We were looking at the command summary, and we said we are summarizing everything in the data set. And what R does, it only gives summary statistics for continuous variables, variables that are labeled interval. That's where you see the summary statistics. R knows that we cannot summarize gender, we cannot summarize job category, neither can we summarize minority. So that tells you that summary statistics is only important or can only be done for continuous variables. Okay, we can also be more specific, and we compute the minimum value of salary, the maximum, the mean. So this is when you see the first part we are giving is when you want to get each value. You can see it goes up to standard deviation. So we want to get the minimum, we want to get the maximum. So let's run line 69. Everybody put your cursor at line 69 and run. So when you run line 69, it has summarized, given you results of the minimum value, which is 15,750, the maximum value, $135,000. Then we have the minimum value and also the standard deviation. Okay. So that is the summary statistics for that variable salary. We can also add on and get the range, the variance, the median. So we can run line 71. So it is telling us that the range is between $15,750 to $135,000. So the difference gives you the range. And then we look at the variance, it is really quite a big number. And then the median value is $28,875. That is the salary earned. Okay. So here we can compare the mean and the median. Since the mean is greater than the median value, in the chart, is the data normally distributed or skewed? Since the mean is greater than the median, in the chart, is the data normally distributed or skewed? Okay, some people are saying skewed, not skied, it's skewed. Okay, skewed. Okay, great. Yes, if the mean is greater than the median, the data is not normally distributed and is skewed to which side, left or right? Let's see in the chart. Because remember, you're going to analyze your data and we want you to write around your data. So some are saying left and some are saying right. Let me not give you the answer now. Since some are saying right and some are saying left, let's go and draw the graphs and see what it shows us. So we are going to keep that question in the back of our mind and we will look at it. So we've been summarizing continuous variables. In the same script, I have put comments. So in case you're lost, just read the comment. Now, what if we want to summarize gender? Since gender is categorical variable, we are going to run a frequency distribution table. And we can get that using the command table. So we write table, employee, and the employee data set, we want only to consider gender. So that's line 73. So let's run line 73. And there we are. We're looking at gender and it says there are more male than female, but these are counts. This is the frequency. So how about job category? You do the same. This time I have named, instead of running the table command the way it is, I have named my results job and assign to table in bracket employee $ job cut. So let's run line 76. And when we run the object, it now gives you the output. It shows us clerical. Under the console, if you go there, you see clerical, you will see custodian, and you will see manager. But now these are just frequency values. We want to standardize and present this data in a format that can be understood by everybody. So we are going to change these counts to proportions and then also percentage. That's where we are going. These things, we did them yesterday. I'm just starting with them because, you know, it's like when you want to eat food, there is no way you're going to start drinking, let's say eating cassava before you drink soup. So it's like a protocol. You have to do those things first before you go to the nitty-gritty of EDA. So we first have to have a feel of our data by using frequencies. That's why I'm doing this, but we did it yesterday, so we should be really good now because this is a recap. So line 78 says prop.table. That gives us the proportions for job. So if I click line 78, I see the proportions. You can see in the console, you see clerical has 0.765, custodial 0.05, manager 0.1. And if I want to change this percentage, I just say round to 2 decimal places, and the prop.table, I want you to multiply by 100 and round off to 2 decimal places. So that's line 79. So let's run that. So you see now we have proper percentages, which can now be presented in a paper or online, or you are presenting on TV to those farmers in your village. They will be able to understand that better than the numbers that you had before. Okay, in the chat, is there anybody who has a problem in the chat? Is there anybody who is left behind? Anybody left behind? Scroll the console, we cannot see the results. Those results should be the same. Let me scroll. That's going down, so I am going up. That's where it ends. But what I can do, I can make it a bit wider. So this is what I have. Okay. Okay, so let's go to, I remember yesterday my colleague did data visualization. We are going to do a few things relating it to the data set and also relating it to the reason why the data was collected. Okay. So we are going to start with graphs. So we want to draw a bar plot for gender. We cannot just say bar plot gender. We need to create a table and then draw the bar plot. So the command is bar plot in bracket table, in bracket employee, look for gender, and then close the bracket. So line 87 is the one that is going to help us construct the bar plot or the bar chart. So if we run that, we get 2 bars, one for female and one for male. And it's already showing us that the female are less than the male. But remember, on our y-axis, we have counts again, not percentages. So remember, if you want to do percentages, you just copy you can copy this line 78 and paste it here and have percentages. So maybe we can try that. So I'm copying line 79, I do copy, and I want to paste it here. Let me just paste it here. And what I'm going to do, I'm taking the bar plot command, copy, and put opening bracket and paste it. I hope you're following, and then close bracket. Let's see. So when you're pasting, you see red coming on the side showing that you're doing something wrongly, but after it has been written correctly, the red disappears. What does this indicate? Let me just run it and see whether it works. So it's a bar plot and we round off to percentages. So let's run and see. Yeah, it has worked. So there's no problem with it. So what we wanted is to present our data so that the y-axis has percentages. So you can go ahead in here and actually adjust the scale. Some of the things you can go to Google and add on. You know, we can't do everything in the shortest time, but it's like giving you a highlight, and then that highlight scratches your brain to learn more. That is what we are doing. So we are scratching the brain to learn more. Okay. Okay, so we've drawn our graph with percentages. Now we are also going to draw job cut. We are also going to draw a bar plot for job category. The same command, line 92. So you can see once you know how to draw a bar chart for one category variable, then you will know the same thing for another categorical variable. So here we just run line 92 and we have our bar chart, and the bar chart you can see it is showing us that the clericals are more, we have fewer custodial, and the managers are not, and also not many. Sometimes you may want to present it horizontally. My colleague talked about that. So line 95, it is the same as line 92. The only thing we've added is horizontal is equal to true, gives you a graph in horizontal position. So it depends on the way that you want. So if we run that, you can see that has been flipped. Okay, ladies and gentlemen, any problem in the chat? Let me see in the chat. Please, what do you mean by dev off? Dev off is a command which removes the graphical information from the graph window. Let me see. So if you run it, it takes off under plots, all those plots will be cleared. Peter says he's lost. When you say you're lost, tell me where you're lost, and so that I can pick you up. If you're on Kampala Road, I'm going to run with a border and pick you. If you're near Forum, that is very fast. My colleague Helen will pick you, but tell us, where are you lost? Which line are you on? You're moving so fast. Okay, praise. I'm going to reduce again. I am also lost. Peter and somebody else are lost. Can you please move your script to where the dev off is? Okay. Can I get the attendance link, please? Okay, that one's her problem is the attendance link. Please watch the video after. Very good, very good. You watch the video after, otherwise we are going to be rolling up and down. But I'll go back a little, okay? Because now we are left with 9 minutes. So in 9 minutes, I don't want to introduce anything, but I'm going back to dev off. So I said, when we run line 90, if I run it, the graphs under plots disappear. That is the job of dev off, and open and close brackets. Then if you run bar plot in bracket table employee, we want to draw a bar chart for job category. That's line 92.
Excuse.
Yes.
No, there are people who are up to now asking to be given the scripts. The script is in the folder.
The script is in the folder, ladies and gentlemen. The folder was posted yesterday. Go to the link. Helen, can you help me post the link again? Please just click that link. You will see this
over and over again. Okay.
Okay, thank you. Please go to day 3 and get the link. And if today is your first day to attend, please, I encourage you to go to the YouTube and listen. And listen to we've already talked about these things, and today actually I thought we would move and finish this practical because it has a bit of recap and a few other new things which you've left behind. But since we've run out of time and it's 8 minutes to 5, we are going to stop here. So the two things, yes?
Yeah, I just want to emphasize one thing. Yesterday I said it's not advisable to work from a download folder. Please, for each day, just create, maybe the best thing to do would be to create a folder on the desktop, and then you pick all the important, the scripts, you pick your data set and put it there so that you set that as the working directory. Will be a lot easier than trying to work it from the download folder, which is not good. Thank you.
Thank you, Thomas. Ladies and gentlemen, since we've run out of time, I think let's stop here and pick up tomorrow. But please, since you have the script, go ahead and run the script. And in case you get stuck, tomorrow it will be like brushing. You learn more than when you wait for me to do for you everything. I don't mind doing the things, but I want you to learn so that when you leave this session, you've already learned something. Tomorrow, I'm going to buy a speed governor because I've been told that I'm fast. I'm going to buy a speed governor so that I am a bit slow. Okay. Ladies and gentlemen, thank you so much for your attention. I encourage you go to the YouTube and listen to what Dr. Helen taught yesterday. All the things were covered. And when you come here, you'll be just refreshing yourself. Thank you so much, ladies and gentlemen, for paying attention. I hand over to the host, Dr. Runyararo or Amitu. Thank you, participants.
Thank you so much, Professor Balaba, for this session. I can see from the charts that they say today has been so interesting. Now people are understanding the R. I want to hand over to Professor Rogerio before we officially close. Professor Rogerio, over to you.
Thank you, Dr. Runyararo. I would like to ask you to clap to the facilitator, please. They have been wonderful in bringing us the art, our knowledge. I'm sure after this session, people will be able to use art, master art, to do analysis and solve the problems of Africa in terms of doing research or completing their studies. That was really, they're being wonderful. Thank you very much. It's only that I have to say at this moment. Thank you.
Thank you so much, Professor. Thank you so much, our facilitators. Thank you so much, the participants. Let's meet again tomorrow at the same time. Have a good evening. Bye.
Bye. Thank you.
Bye-bye.